In order to do this circular review, you need to stop this video and get a stopwatch. Got it, ready to time, and go. 1, 2, 3, and stop. Okay, now pause the video and take the time to really think about motion and in a circular manner, and calculate the period that it took Einstein to go around one complete circle. You know how to do that. It took a total amount of time and divided it by the number of times that it went around. So it went around 4 times, and take your time, see what you get. I ended up with a period of 1.82 seconds. Now we're going to use that in our notes. So today's goal is we're going to connect circular motion to more circular motion. So I'm going to first write down the period that you calculated. I got the period from Einstein going around was 1.82 seconds. So it took Einstein 1.82 seconds to make one complete circle. Now, let's first calculate the actual tangential velocity that Einstein was going. So as he was traveling around in a circle, so there he was going around in a circle, he went around his circumference, and of course we know that circumference is 2 pi r. Okay, and it had a specific radius there. All right, the radius was 13 centimeters. So there's our r, so r equals 13 centimeters, which of course equals 0.13 meters. So if I want to know my speed at which he was going, we need to have our speed, velocity, over displacement over time. And our displacement that it was going was 2 pi r, and time is our period. And that will give us how fast Einstein was going around in a circle. I'm going to do that, just take a second. So now we can say that Einstein was traveling around the circle at 0.45 meters per second. Let's take a look again at Einstein, but now he's not at the same place. He's sitting a little bit closer to the inside of his rotation on the same record player, going around at the same speed. How do we deal with that? All right, well, let's take a look. If we slow Einstein down, let's slow our thinking down. He is still going around a circle at the same rate. His tangential speed has changed, and I'm going to have you do a lab about that later. But we can't just say speed. We would have to say something like his angular velocity. And it's angular velocity that will start pulling in our ideas about tangential velocity, radius, and how fast he's going around in a circle. Let's take a deeper look at what we have in our data packet. In topic 6.1, we have this, of course, is still velocity, but V is for velocity. That's a lowercase v after our last unit. And this W is omega. And omega is our angular velocity. This is telling us how fast something is going around in a circle. And then, of course, r is still radius. Okay, so radius. In our new topic, our topic 9.1, from topic 9.1, we're going to introduce this a better idea of what angular velocity is. So here's our omega. And if you think about it, angular velocity is just how fast something is going around the circle. And that circle, if you were stuck on that record player, it doesn't matter your radius. It only matters how fast the whole thing is turning. Okay, so our angular velocity is going to be equal to how fast you go through 2 pi and how much time it takes you to go around that complete circle. The units of omega would be in, of course, radians per second, or rads -1. Yeah, kind of looks like that. And now, if we know our angular velocity, we can bring back our high-level topic back into our 6.1 SL topic by saying, if I know how fast I'm going around a circle, if I just times that by how big the circle is, I can get back to my regular tangential velocity. This is how fast it's rotating. This is how fast it's going if we were to let go of the string. So your job now is to go twirl something and calculate its tangential velocity, its angular velocity, and its acceleration. But be careful.